these are your 3-1B notes, systems of equations. So we're still solving system of equations. In the last section, we solved by graphing. And as you go through that, you realize it's very time consuming. It's not always accurate because they don't always intersect at a nice intersection, whole number intersection. So we have a couple other options. So today we're going to concentrate on solving by using substitution. So substitution is a great method. You simply isolate a variable in one equation. Sometimes the step's already done for you. So if the equation's already set up as x equals something or y equals something, that step is done for you. And then you just simply substitute that value into the other equation. So if you look at this example here, that's exactly what we're talking about. I have y is equal to 2x. So that means that y and 2x are exactly the same value. So wherever I see y over here, I can replace it with 2x instead. And so what you get is 2x from the original second equation plus 5, but rather than writing times y, I'm going to replace it with that 2x from the first equation. And it still equals negative 12. So now I just solve, and what happens when you substitute, we no longer have an equation with two different unknowns. Now the only unknown that we're looking for is x. So I have 2x plus 10x, when I multiply 5 times 2, is equal to negative 12. And you solve for x. 2x plus 10x is 12x equals negative 12. Divide by 12, divide by 12, x is equal to negative 1. We're not done because the answers are still the same as they were in the previous assignment. The answers are still a set of ordered pairs. So now that I have x equals negative 1, I can choose one of my two original equations, either y equals 2x or this 2x plus 5y equals negative 12, and plug it in or substitute it back in for x. I think the easiest one is to just kind of work in a circular fashion. So since I already plugged into the second equation, I'm going to take this negative 1 value and plug it into the first equation. And so when I do that, I get y equals 2 times negative 1, and therefore y is equal to negative 2. So once you get both solutions, you put them together as an ordered pair. So my solution here is negative 1, negative 2. This actually was the solution of the first problem that we did using graphing. So same exact two equations. If you were to flip back through your old notes, you would see that when we graphed, these two lines intersected at negative 1, negative 2. Next problem. So this one is what you guys did in your as your practice problem. But instead of having to get it equal to y, we just got to get one equation equal to a variable. So you actually have 4 different choices. If we wanted to get this y by itself, I would simply divide both sides by 2. But then you're plugging in an ugly fraction. Not a big fan of that. If I wanted to get the first red x by itself, I could divide both sides by negative 3, but same issue. You're going to have an ugly fraction. The best variable to get isolated and get by itself is the second y. That y value doesn't have a coefficient in front of it, so you wouldn't have to divide anything. We just simply have to move or subtract the 4x from both sides. That leaves me with y equals 5 minus 4x, and that is what y is equal to, so I could substitute that into the red equation and solve. Some people have a problem with me putting the minus 4x at the end. I'm not graphing, so I don't care about slope and y-intercept or putting it into y equals mx plus b. If you want to put the negative 4x out in front, that's fine. Just make sure it has the negative sign in front of it. So I'm going to take this value. I like to draw the arrow, and I'm plugging it in for y because that's what it says. It says y is equal to 5 minus 4x. So when I solve this, I have the 2 times my substituted value for y, 5 minus 4x, is equal to negative 3x. And now as you look at that equation, the y is gone, and all I have to do is solve for x. I'm going to distribute my 2 through, so I get 10 minus 8x is equal to negative 3x. Trying to get x on one side, the number on the other. I'm going to add 8x to both sides. 10 is equal to 5x. Divide both sides by 5. X is equal to 2. We're halfway there. We got one of our coordinates. After you get x is equal to 2, you need to plug it back into one of these other equations. You actually have 3 different places you could plug that equation into. We could plug it into this equation, not my favorite. You can plug it into this equation, really not my favorite. Or we could plug it into this equation here. And that one's all set up to give us a y value. So I really like to plug it into this equation. But you have a choice. You can plug it in any one of those 3. So if I plug it in here, y is equal to 5 minus 4 times 2. And then y is equal to 5 minus 8. Y is equal to negative 3. So my solution here is the ordered pair 2, negative 3. Okay, so those first 2 examples, I showed you where the lines would intersect if you were to graph them, and so there's one solution. These next 2 examples are when you had parallel lines, and if you had the same line, how that looks as a substitution problem. So if the lines are parallel, then we would say no solution. If the lines are the same line, we would say infinitely many. How that looks as a substitution problem is your variables are going to go away, and you'll be left with an equation. If the equation's true, it's infinitely many. So if you're stuck with 3 is equal to 3 or 5 is equal to 5, that's always true, infinitely many. If you're left with an equation that doesn't make sense, like 5 equals 7, that's not true. 5 does not equal 7, so there'd be no solution. So in either one of these special cases, the parallel lines and the same line, when you solve using substitution, both variables disappear. So I'm going to quickly show you that. I'm going to plug this y value, 2x minus 3, into this equation. 6x minus 3 times the quantity 2x minus 3 equals 9. Distribute. So I'm left with 6x minus 6x plus 9 equals 9. And you can see that the 6x and the minus 6x cancel. And I'm left with 9 equals 9. So I have to interpret that that's the same line that's infinitely many. When does 9 equal 9? Always. For number 4, when I substitute, I'm going to take this y value, which is 3x plus 4, plug it into this y. So 3x plus 4 minus a 3x is equal to negative 7. The 3x and the negative 3x cancel. I'm left with 4 equal to negative 7. That's never true, so your solution is no solutions. So here's your lesson summary. And here's your practice problem. So if I were to solve a system and I got 4 equals 4, interpret that solution, and then I need you to solve using substitution that system of equations. Good luck.